Hello, my dear students. Today we are going to discuss the states of matter, fifth chapter of the 11th standard. As you are aware, there are three states of matter: solid, liquid, and gas. And you also might be aware there are five states of matter. Fourth one is plasma, and fifth one is Bose-Einstein condensate. And plasma is the state which is superheated state due to which the sun and star glows. It is superheated state and due to which the sun and stars glow, and this is super cooled state. And actually student, there are seven states of matter will be there. If you require this one, you can make contact me back. And the next topic of states of matter is that force of attraction. There are three types of force of attraction lies in the syllabus of 11th standard. Number one is dipole-dipole force of attraction. For this to understand, we will take the example of HCl. It is one positive and one negative charge, so it is called dipole-dipole force of attraction. It is also known as dispersion force, and it is also known as weakest van der Waals force of attraction, weakest van der Waals force of attraction, and this is also known as keystone forces, dispersion force, weakest van der Waals force of attraction, keystone forces, and this is also known as London force. And HCl is in a polar covalent compound that you know very well. Then come next is the dipole, induced dipole. Means of that, if we have one molecule which are having dipole, suppose that I can take the example NaNO3 ionic compound, positive negative, I can take HCl. So one is positive charge and one is having negative charge, and if it hits a neutral molecule, number of time whenever it hits a neutral molecule, it induced means inspirations, and this molecule momentary will get dipole, positive and negative will be induced. Now come on third force of attraction, that is hydrogen bond. And when I am going to explain this one in this way, that whenever hydrogen make its bond with highly electronegative atom like as fluorine, oxygen or nitrogen, and I simply discuss with the student, whenever hydrogen call a phone, the spelling of my phone is FON, but there are actually three elements: fluorine, oxygen and nitrogen. These are the highly electronegative atom in whole the periodic table, and I give them name Raman, Meghnath and Kumbhkaran. So means of that, whenever hydrogen make its bond with a highly electronegative atom, it is called hydrogen bond, and hydrogen bond is of two type. Number one is intermolecular hydrogen bond. It is formed between two different molecules. Like as I am showing you the example H2O. So this HOH, then it will make dot dot and attach with other molecules of the water. Then O, H and H. Inter means of between two different. Whenever the bond is formed between two different countries, that is called international match. A game is played between two different schools, international. Intramolecular, whenever hydrogen make its bond with its own molecule, it cannot get attached with some different molecules. Like as I am taking orthonitrophenol, this is the orthonitrophenol. Look guys, and salicylic acid is OHCWH. And what you come to know here, this OH and NO2, its bonding goes in this way. The hydrogen of orthonitrophenol get attached with its molecule in itself, like that. So whenever this is in a single bond, whenever a bond will come in this way and hydrogen cannot attach with another molecule, it is called intra. Due to this, the melting and boiling band are weak and oxygen is attaching here. But in the paranitrophenol, as we have seen that hydrogen of one can attach with the another molecule. Suppose that this is NO2. But we will take here one different molecule of paranitrophenol. So this O and this H of this paranitrophenol will be attached with this oxygen and will give you the intermolecular hydrogen bond. So this is what a little bit summary. And in states of matter, there is a solid, liquid and gas. Solid possess less energy than liquid and liquid is less energy than gas. So thermal energy, solid is having less energy, that's why they are not moving. And solid will shows only oscillatory motion. One particle is surrounding by itself which we cannot feel, like as the gravitation force of earth we cannot feel. This is solid. If we press it, we feel that it cannot be pressed, but it is pressing little bit, we cannot feel, that moment will come. And if this is in a particle, this is another particle, and motion is going from this particle to that particle, that is called translatory motion. Translatory motion never observed in the solid, but the oscillatory motion has been observed. And if you will discuss this one in one of the physics past teacher, we will explain you much more better. And thank you guys. In next class we will discuss the laws of the gases law, orbit by the gases. Thank you. Bye bye.